Today's video is going to be called Son of Frankenstein. So I'm going to have a go at Frankenstein Lead Screw Mark II, and this time I'm not going to use any welding. And let's see how that goes. So it's this lead screw that I'm going to tackle next, and I'm going to attempt to make the lead screw in the same way with sandwich pieces of metal, but I'm not going to use any welding, and we'll see how that goes. So let's have a look at the amount of backlash I've got at the moment. So I've got this much backlash, almost half a turn. And we'll see how much better it is once I've done the additional lead screw nut made from sandwich metal. I'm going to do the same thing again using the plates of metal screwed on, but this time instead of welding the corners here, all I'm going to do is bolt them all together. So this time I'm going to cut them accurately, sandwich them all together, and this time I'm just going to put bolts through there to attach them to the old lead screw. The problem that I can see is that as I put the sandwiches together, as with the other welded lead screw, I'll have gaps. And then if I screw the bolts in, it will squeeze all the plates together, and that will make it more difficult for the lead screw to move. So I'll show you what I'm going to do to alleviate that problem on the whiteboard. So the problem is going to be when I sandwich all of the plates together, there's going to be a gap between each one, and without welding it over the top, if I put a bolt through there, it will squeeze all of the plates together, and that will affect the thread. So what I'm going to do is between the plates I'm going to put what amounts to a washer, but it's going to be made of the same material that the plates are made of. Now I need to make them in two parts, so I'll do a top and a bottom. So once I've put these bolts through the plates, the washers, and into the existing lead screw, it will stop the plates from compressing, and that will allow the lead screw to maintain its shape and be a lot smoother when the lead screw bar is turned with the handle. So you've got to marry these plates up in the correct orientation, so the hole this side lines up with the hole there. So you've got to put them on with the correct orientation. You can actually flip it over and then this hole doesn't line up with that hole, so make sure that you line them up in the correct orientation. So one of the other causes of the backlash was the movement that you get in the spigot itself. So you can just see it moving there, and it actually moves from side to side as well as up and down. The way that I've chosen to eliminate that is to make a little washer, and that needs to be countersunk because it's got to lay flush so that the tool post can sit on top, and then you put a countersunk screw in there, and that holds that spigot nicely in place. Okay, that holds that spigot nicely there. So that's that part of the backlash dealt with. So I'm just adjusting the sideways movement on the cross slide. Once I put the compound tool rest on, I can't get to these two screws. So that's got to be right before I put that on. So this particular fix worked well on this cross slide. So let's see how it's worked on this cross slide without any welding. So the action is very smooth, really pleased with that. Okay, the backlash. Okay, I can't even move that, so that is exceptional. There's the backlash. The backlash amounts to that amount of movement. Okay, so very, very pleased with that. It's a lovely smooth operation there. So this is really going to help with the chatter that I've been experiencing when I've been cutting metal on this job. So again, very pleased, and thanks very much for watching.